Good morning, everyone. So today we'll be looking at Chapter 9, Probability of Combined Events. So in this chapter, we'll be focusing on two parts mainly, which is dependent events and independent events, as well as mutually exclusive and non-mutually exclusive events. Okay, and at the end of the chapter, we will look at the application of probability of combined events. Right, so let's start. First thing first, what is a combined event? So a combined event is a combination of two or more events in an outcome. Okay, and in this first part, we will be listing out the possible outcome for combined events. Right, so for example, what are the possible outcomes of two pupils playing rock, paper, scissors? So you know that when two people play rock, paper, scissors, so I have number 1 and I have pupil number 2. For the first pupil, when they play rock, paper, scissors, any result will come out, right? So pupil 1 might show rock or paper or scissors. Pupil 2 might also show rock, paper or scissors, but we don't know what is the outcome. They could, pupil number 1 could show rock and pupil number 2 could show paper. Or pupil number 1 could show scissors and pupil number 2 could show scissors as well. We don't know. But in this part, we don't have to guess exactly what are the results, but we just guess what are the possible outcome. Okay, apakah kemungkinan yang berlaku? What are the possible outcomes? Okay, so we can list the possible outcome using two methods here. Okay, first method is listing. Okay, is listing possible outcome. Second method is using tree diagram. Okay, let's look at it one by one. So, listing possible outcome. Let R as rock, P as paper, and S for scissors. Okay, and then A. Let A be the possible outcome for pupil 1. So pupil 1 could show either rock, paper or scissors. And then let B be the possible outcome for pupil 2. So similarly, pupil B might also show rock, paper or scissors. Okay, but we don't want to see the outcome individually, okay, because they are playing the game at the same time, right? So we will list out the number of possible outcome for the two students. Okay, which will be represented by letter S. So S is known as sample space, or also known as the number of possible outcomes. Okay, number of possible outcomes. Let's see. If let's say pupil 1 shows rock, pupil 2 could also show rock. Pupil 1 could show rock, pupil 2 could show paper. Pupil 1 could show rock, pupil 2 could show scissors. Pupil 1 could show paper, pupil 2 could show rock. Okay, so we just list out all the possibilities. Okay, so pupil 1 could show paper, pupil 2 could also show paper, pupil 1, paper, pupil 2, scissors. Okay, apologies. Okay, paper or scissors. And then pupil 1 could show scissors. People 2 could show rock. People 1 could show scissors. People 2 could show paper. People 1 show scissors. People 2 show scissors. So those are the possibility that could come from the from the 2 students, right? And the number of possible outcome we calculate. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. The number 9 possible outcome from this case. Now we can actually know the number of possible outcomes using a formula, okay, whereby the number of possible outcomes equals to the number of possible outcome of event A times with the number of outcome of event B. So event A and B refers to the possible outcome of what we have in the question. So for example, event A is the number of possible outcome for pupil number 1. So pupil number 1 could either show rock, paper, or scissors. So we have 1, 2, 3. 3 possible outcome for event A. Event B is outcome for pupil number 2. So pupil number 2 could also show rock, paper, and scissors. So 1, 2, 3 possible outcome. So 3 times 3 equal to 9. So from here we can confirm that we have 9 possible outcome for the student's game. Now let's look at the second method, which is the tree diagram. Okay, so tree diagram is almost similar. So we'll have pupil 1 and pupil 2. So pupil 1 might show either rock, paper, or scissors. Okay. And then if pupil 1 shows rock, pupil 2 might show either rock or paper or scissors, right? Because it's possible for them to have different to show different results here. Okay, so if pupil number 1 shows paper, then pupil number 2 might show rock or paper or scissors. If pupil number shows scissors, then pupil number 2 might show rock, paper, or scissors. Okay, so what are the outcomes? Pupil 1, rock, pupil 2, also rock, or pupil 1, rock, pupil 2, paper, pupil 1, rock, pupil 2, scissors. Pupil 1 might show paper, and pupil 2, rock. Pupil 1, paper, pupil 2, paper, paper, scissors. Okay, and then pupil 1, scissors, pupil 2, rock, and we have scissors, paper, or scissors, scissors. So these are the possible outcomes listed using the tree diagram. So if we calculate 1, 2, 3, 4, 5, 6, 7, 9. So the number possible outcome is also 9. So this is how you calculate or you list the possible outcome either using listing method or using a tree diagram.